All right, so now we are going to talk about zeros of polynomials, or polynomial functions. And where we get to the definition, you want to think of zeros of a polynomial are the same thing as ax intercepts. You know, because basically a zero is a number that if you plug it into a polynomial, you get zero. Okay, so that by definition, that's the x-intercept. So finding the zeros, basically the real zeros of a polynomial, that amounts to finding the x-intercepts. So a real number r is a zero of a polynomial function f if f of r equals 0. Now there are 4 conditions which are equivalent. That means if any one of these 4 conditions is true, then the other 3 are true as well. So if r is a 0 of f, well, that means the graph of f passes across the x-axis at r. Okay. Now, one thing that's maybe not as obvious is that this also means that that x minus r is a factor of f of x. That means f of x can be written as x minus r times some other polynomial. Okay, and that's another way of saying is that x minus r divides f of x. Now you can clearly see, hopefully, that if f of x is in this form, if you plug in x equals r into this equation, this factor becomes 0. Okay, so that means that 0 times something is 0. So that means f of r will be 0. What might not quite be obvious is the other direction. That why do we know that x minus r has to divide f if r is 0? That's something that involves long division of polynomials, and we won't be covering that here. But the important thing is that the factor is x minus r. It's not x plus r. Okay. All right. Now the factor x minus r might occur several times in the factorization. So the number of times that x minus r occurs as a factor is called the multiplicity of r. Okay. Another way of looking at it is if x minus r divides f of x, but x minus r raised to the k plus 1 does not divide f of x, then we say k is the multiplicity of r as a 0 of f. Okay, so basically to find the multiplicity, you have to factor. You have to factor f of x and see how many times x minus r occurs. And we'll see why this is important when we're graphing later in a few minutes. So let's look at some examples here. X squared minus x minus 6. Let's say we want to find, in all these examples, we're going to find the zeros and their multiplicities. This factors as x minus 3 times x plus 2. Right? If you FOIL this out, you should get this. All right, we see x minus 3 is a factor, so that means 3 is a 0. And because x minus 3 only occurs once, we have 3 has multiplicity equals 1. X plus 2 is a factor. Well, that's the same thing as x minus negative 2. So negative 2 is the other 0, and that multiplicity is also going to be 1. Okay. Hopefully you see why it's negative 2 and not positive 2 is because it's plus. If you plug 2 into here, you don't get 0. All right, part B, we have a third-degree polynomial, x cubed plus 3x squared plus 3x plus 1. I'm just going to give the story away and tell you that this is x plus 1 to the third power. Okay. And don't worry about, if you're not able to figure this out, don't worry about it, but you can, if you want to multiply it out and check this later, you can. So that means x plus 1 is the same thing as x minus negative 1. So negative 1 is the only 0, and we see the multiplicity will be 3. All right. Maybe I should just write this as this is the same thing as x minus negative 1, okay, to the third. Okay, just like we have the x plus 2 is the same thing as x minus negative 2. Okay, that's why it works. All right, the next one, x to the fourth plus 3. if you try to factor it, well, it's going to be very challenging, but I think you should be able to see that this has no zeros, because there's no number x for which this is ever 0, because x to the 4th is always positive or 0. Okay, and if you add 3 to it, that's still going to be positive. So so this expression, if you plug any real number in for x, the least this can be is 3. Okay, so it can't be 0. This is not 0 for any x. Okay, so there are no zeros. And then in this last one, if you can you see what the zeros would be? We have an x plus 3. That's the same thing as x minus negative 3. Okay, so negative 3 is a 0. X minus 1 is a factor, so that means 1 is a 0. And x plus 7 is a factor, so negative 7 is a 0. X plus 3 occurs once. X minus 1 occurs 4 times. X plus 7 occurs once. Okay. And what about this negative 2? Is negative 2 a 0? Well, no, because this is not x minus 2, this is just negative 2. And obviously this will never be 0. If you plug negative 2 into this expression, you won't get 0. Okay, so because negative 2 is just a constant, we kind of ignore this. And in general, if you see any factor which can never be 0, we just ignore it. All right. Now, if we go in the other direction, suppose I ask you to find a polynomial with the following zeros. And let's say in part A, let's say we have, want you to find a multiplicity where the zeros are 2, negative 1, and 0, with multiplicities 1, 2, and 1. This isn't as hard as it might seem, because if we want to if any polynomial with 2 as a 0 is going to have x minus 2 as a factor. Any polynomial with negative 1 as a 0 has x plus 1 as a factor. And any polynomial with a 0 as a 0 must have x minus 0 as a factor. Okay. And we want the multiplicity of 2 to be 1. We want the multiplicity of negative 1 to be 2. And we want the multiplicity of 0 to be 1. And so we just have to multiply this out, and that's going to be our polynomial. And in fact, I'm not going to multiply this out. I'm just going to say that this is the same thing as x minus 2 times x plus 1 squared times x. Okay? And you can leave this as is. I think on the online homework you might have to multiply this out, but certainly on a quiz that I'm giving, you can just leave it like this in factored form. Okay, why don't we pause the video and do this next example. Same thing, and then, okay, negative 7 means x plus 7 is a factor, and the multiplicity is 1. This means x minus 5 is a factor, and the multiplicity is 3. And this says that x minus 6 is a factor, and the multiplicity is 2. Okay, so there's your polynomial. Yeah, and again, you can leave these in factored forms, and hopefully you can see that this tells us, if a polynomial is in factored form, it actually tells us a lot more information. And particularly, you can basically read off the zeros or read off the x-intercepts. So, for example, we can see that this graph will cross the, well, at least we'll have an x-intercept at negative 7, 5, and 6. And we can actually, we can see a little bit more than that, because the multiplicity of a 0 tells us something about the graph. If the multiplicity of if R is even, then the graph touches the x-axis. And if the multiplicity is odd, the graph crosses the x-axis. Now, why is this true? Well, because, for example, if we take x minus 1 to the 3rd power, okay, this is going to change some, because 3 is an odd number, this is going to change sign. Okay, when x is less than 1, this is negative. So we raise it to a third power, that's negative. If x is bigger than 1, this is positive. Okay, so we can see that this will change sign at 1. It goes from negative to positive. Okay, but whereas if we have x minus 1 to the fourth power, okay, because 4 is even, anything raised to an even number is going to be positive. So we see that this will, so because the factor changes sign, that means the sign of the whole function will change as well. Okay. So as an example, let's just maybe go back to here. What we see is our zeros in A are going to be at -1, 0, and 2. And we can see that the graph is just going to touch at where the multiplicity of even at -1. That's right here. And in fact, and of course, it will cross the x-axis at 0 and 2. So in fact, the graph will look like this. Actually, no, it'll look something like this. Actually, let's put a minus sign out here. So that's what this will look like. We'll talk more about this, about why we need that minus sign later on. But this is kind of live, so that's what it is. All right. Just one other thing. The maximum number of turning points of the graph of a polynomial function is always bounded by the degree -1, one less than the degree. Now that doesn't mean that we will have this number of turning points, but that just says that's the most we can have. Certainly when we have if we have a quadratic function like this, the degree is 2, 2 minus 1 is 1, and every parabola has exactly one turning point, right? That's the vertex. Now, if we have something like y equals x cubed, okay, this is a third degree polynomial, but which means that the graph will have at most 2 turning points, but in fact, it doesn't have any, right? Because we know the graph looks like that. Okay. However, in here, with our example up here, we have a fourth degree polynomial. Okay, if we multiply this out, we get, this is going to be minus x to the fourth plus some other terms. So the degree is 4, and in fact we have 1, 2, and 3 turning points. Okay, so we might have this many turning points, or we'll have fewer than that. Okay, and then the proof of that is a little beyond the course, and we're not going to worry about that.